Pre-statistics. Integer exponents. Lesson objective. Use the property of exponents to simplify expressions. Lesson objective. We'll begin with the definition. For any counting number n, b to the n power is b times n factors of b. We call b the base, and we call n the power. In this example, we have 3 to the 5th power. So the base is 3, and the number 5 is the exponent. So we would say this is 3 raised to the 5th power. The exponent tells me the number of times I multiply the base. So 3 to the 5th power, which is 243. Two powers of b have specific names. We refer to b to the 2nd power as the square of b, or b squared. We refer to b to the 3rd power as the cube of b, or b cubed. To clarify, for negative b to the n power, we compute b to the n before finding the opposite, because we want to follow the order of operations. We do exponents before we multiply by a negative number. So a negative 2 to the 4th means a negative 1 times a base of 2 raised to the 4th power. We compute 2 times 2 times 2 times 2 first. So we do the exponent first, which is 16, and then we multiply it by a negative 1, and we get a negative 16. Now if we want a base of negative 2, we put parentheses around the base, and then we raise it to the power. Now the order of operations says we compute what's in the parentheses first. So this means a base of negative 2, and we want 4 powers of negative 2, which turns out to be a positive 16. And this can be verified on the graphing calculator. If we hit the negative sign, 2, the caret key, which means power, 3, and hit enter, we get a negative 16. If we put parentheses around the negative 2 and raise it to the 4th power, we get a positive 16. Properties of exponents. If m and n are counting numbers, then b raised to the m power times b raised to the n power is equal to b raised to the m plus n power. So when we are multiplying like bases, we add the exponents. B to the m divided by b to the n is b to the m minus n. So when we divide like bases, we subtract the exponents. When we have more than one base raised to a power, we distribute the power. When we have a fraction raised to a power, we distribute the power to both the bases, both to b and to c. And when we have a base to a power and we raise it to a different power, this is the case where we multiply the exponents. Let's see an example of these properties in a problem. Consider these powers of 2. 2 to the 1st power is 2. So when we have a number and we don't see an exponent, it's understood to be a 1. 2 to the 2nd power means I take the base and I multiply it 2 times. 2 to the 3rd power is the base 2 multiplied by itself 3 times, which is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th would be 32 times 2, which is 64. So imagine we have this problem here. 2 to the 3rd times 2 to the 2nd. But another way we can look at it is we can say, well, 2 to the 3rd is 2 times 2 times 2 multiplied by 2 squared, which is 2 times 2. 2 times 2 times 2 is 8. 2 times 2 is 4. 8 times 4 is 32. Now using the property of exponents, since we have the same base of 2, we can simply add the exponents. And we can say this is now 2 raised to the 5th power, and 2 to the 5th power is 32. It's the same answer. So for complicated expressions, this is an easier way of computing. Let's do another example. Imagine we have 2 to the 5th divided by 2 to the 3rd. 2 to the 5th is 2 times 2 times 2 times 2 times 2 divided by 2 cubed. Well, if we compute this, this becomes 32 divided by 8, and 32 divided by 8 is 4. Using the property of exponents, since these are the same base, 2, we can simply subtract the exponents and we get 2 to the 2nd power, because 5 minus 3 is 2, and 2 squared is 4. It's the same answer. Next, if we take 2 to the 3rd power and then raise it to a power of 2, we can think of this as the base, 2 to the 3rd, and then this exponent is telling me how many times to multiply it by itself. Well, 2 to the 3rd is 2 times 2 times 2. Again, 2 times 2 times 2, which is 8 times 8, which is 64. Using the property of exponents, if we take a power and raise it to a power, this is when we multiply. So 3 times 2 is 6, and 2 to the 6th power is 64. It's the same answer. Now next, this time we have two bases, a 2 and also an x, and I'm raising that to a 3rd power. So my base would be 2x, so I have 2x times 2x times 2x, because there's a 3 here. Now multiplying 2 times 2 times 2, and we have x times x times x. X times x times x would be x to the 3rd, because we have an exponent of 1, 1, and 1, and we add those powers and we get x to the 3rd. 2 times 2 times 2 is 2 to the 3rd, which is 8. So the answer is 8x cubed. If we use the property of exponents, 2 has an exponent of 1, so I multiply. 3 times 1 is 3. X has an exponent of 1, so I distribute the 3 again, and I get x cubed. And then we get the same answer, 8x cubed. Imagine we have 2 divided by x squared. So we have a base of 2, and then we also have a base of x, which is being squared. If I think of this as the base, this says take the base and multiply it by itself 4 times. I get this. Multiplying fractions, we multiply the numerator. So this will be 2 times 2 times 2 times 2, which is 2 to the 4th. And then we have x squared times x squared times x squared times x squared. Because all these are the same base, we have x raised to the 2 plus 2 plus 2 plus 2, which gives us 16 divided by x to the 8th. Using the property of exponents, we can take the power, 4, and multiply it to each power to each base. So this will be 4 times 1, which is 4, and then 4 times 2, which will be 8. So 2 to the 4th is 16 divided by x to the 8th. These are the same answer. So these 5 examples were illustrating the properties of exponents using powers of 2. These properties will work for any base. Example 1. Show that b to the 5th power times b to the 3rd power equals b to the 5th power. Solution? We first will write without exponents. So this will be b times b times b cubed. Now we add up the exponents. All these will be a 1. So this becomes b to the 5th. To verify this by using the graphing calculator, we can put the left-hand side in y1, the right-hand side in y2, and see if we get the same answers. So we will have x squared times x cubed. In y1 and y2 we have x to the 5th. And if we go to our table, we can see the values of y are the same for y1 and y2. They're equivalent. Example 2. Show that b to the m times b to the n equals b to the power of m plus n, where m and n are counting numbers. Solution. Again, we write it without exponents. This factor will be the base of b to m factors. This number will be b to the n factors, and that is equal to all the b's to the m plus n factors. To verify this for yourself, you can use different values of m and n and verify it using the graphing calculator, just like we did in the previous example. Example 3, show that b divided by c raised to the n power is equal to b to the nth divided by c to the nth, where n is a counting number and c does not equal 0. We can't divide by 0, that's undefined. Solution. Again, we start by taking the expression and writing it without exponents. So this is the n factors that we have for our base, b divided by c. Multiplying the numerator, we will have b times itself n times, which is b to the n, divided by the numerator will be c times c times c, and we do that n times, and that is c to the n. Again, this can be verified using the graphing calculator and picking values for b, c, and n. Simplifying expressions involving exponents. Property. An expression involving exponents is simplified if, number 1, it includes no parentheses. Number 2, each variable or constant appears as a base as few times as possible. For example, if we have x squared times x to the 4th, we can write that as x to the 6th. Number 3, each numerical expression, such as 7 squared, has been calculated, and each numerical fraction has been simplified. So if we have any numbers as bases, we compute that number. Number 4, each exponent is positive. We'll talk more about negative exponents in a future video. Thanks for watching.